Um, Brian, I know you've got yourself muted right now. We'll get you on in just a minute. Welcome, everyone. We're doing programming for digital preservation and metadata today with Brian Thomas in Texas. And the way the webinar is going to work today, we're going to have Brian speak, and then we'll answer questions at the end. This is part of SERI's fall webinar slate. The last one for the fall slate will be December 17th, so please mark your calendars. It will be the fundamentals of digital processing workflows, and that will be with Nick Canizzo, so definitely come back around and attend that. We will be releasing information on the Spring 2020 SERI webinars in January, but if there's anything anyone particularly would like to hear about or know more about, please let us know so that we can have a webinar for that topic. My name is Morgan Jones King. I'm at the South Carolina Department of Archives and History. So apart from our upcoming webinar options, we also have online recordings produced by SERI. There's the Managing Digital Content Over Time, and that's on electronic resources. And then we have a frequently asked questions on BitRot video, and that is available on YouTube at that link. You will have access to these slides and a recording of this presentation after the fact. So if that URL looks a little long to write down, don't worry. You can get a copy of the slides afterwards. All right, so let me go ahead and introduce today's presenter because I do think we're going to have a chock-full webinar. We're going to try to leave room for questions, but we want to give him as much time to speak as possible. Our speaker is Brian Thomas. He is the Electronic Records Specialist at the Texas State Library and Archives Commission. He's been with them for just about 4 years, I believe, Brian, and he works with them to preserve electronic records held by the Texas State Archives and make them publicly available. Worked on several special projects, and he does quite a bit, as you'll see today, with programming as well. So Brian, I'm going to go ahead and switch you to your, I'll switch you to your first slide, and I'll let Becky turn over privileges to you, and we'll get started.
Hello, everybody. I hope your day is going well so far. Hopefully I don't put you all to sleep. I know this will be a lot of information very quickly. The way I am conceiving of this is kind of a crash course in basics of programming that you can hopefully use in the future to be able to do things like process large-scale amounts of metadata to either divine new bits of information from the collections you have or do things like normalize content. My specific case in doing most of my programming is related to manipulating metadata for digital objects in a preservation repository. So that's kind of the wheelhouse I'm working from. Because it is such a broad topic and complex, I've kind of put a list here of what we're going to try and cover and the order we're going to try and cover it in. If it looks like we're not going to be able to get through everything, I'll just try and power through the last few slides so that we can leave plenty of time for questions and at least thoroughly discuss what it is that's been covered so far. So here we go. A little bit of a disclaimer before going too far. I am self-taught when it comes to programming. I didn't have formal college courses on programming, so if you end up coming across a more formal source, like you do end up taking a college course, or you end up coming across a textbook that contradicts me, it's a decent chance that that's probably correct. What we're trying to get here is the gist of how things are to get you started. Also, I cannot emphasize enough that when you're doing something with programming and digital either items or metadata files or something like that, always work on a copy. I've had a hubris a few times where I'm like, I can just do this and it'll be fine, and then something goes a little wrong and you have to start from scratch. It sounds like something that should be obvious, but just fair warning that reminder that that's something you should probably watch out for. So the big question that comes to mind when looking at this is why learn programming to begin with? One of the things that I've faced in my experience is getting institutional buy-in to be able to devote the time to do this task. It does take a lot of time to learn programming. It's something that you can't spend full time, like 2 weeks of just pushing through. It takes time to simmer in your mind until it finally clicks. And it does have a steep learning curve, as well as a lot of frustrations at the beginning when you're first getting used to the way things work. However, once you're over the curve, the payoff is well worth it. What you're doing is, the first bullet point here is kind of like a nod to what we're probably thinking in the back of our minds, which is to make sure that we are doing the best of our ability, and that if for some reason there's layoffs or legislative issues where funding is going to be there, that you're going to be one of those people that's indispensable. But the reality is what we're really trying to do is get a lot more done in less time in a convenient way and automate tasks that are either not scalable to a human level or that are simply not possible in reality with the way people work. For instance, you could do something, start it off by hand, and just continue trucking through and do a project that might take 2 years, or you could spend 2 months learning how to get it done using programming and do that same amount of work in 2 weeks once you get over that first hurdle of how to do programming. So, an elevator pitch, I think, is something you should have available if you're trying to make this case. I'll read this out, but something to the tune of learning a programming language is useful because it will ultimately increase productivity of the digital archives program. It allows for automation of some, but not all tasks that would not be feasible to do at scale, as well as some allow to complete some tasks that are not feasible for people to do in general. It does take time, but the return on investment is well worth it, and it is an investment that continues to pay off into the future. So, down button does not work. The question then becomes, if you have institutional buy-in, what are the languages that are worthwhile to try? So, if you are thinking about stuff you do right now, whether or not it's programming, if anybody is working with hand encoding HTML or working with XML, that's something that is technically programming, as people continue to try and point out to me. If you're just starting out, you want to look at the higher level programming languages, things that are meant to be fairly easy for a beginner, natural language usage, like you can just say a sentence and something you can think of as a sentence and it'll execute. Python is something that I've used, and all the examples we're going to go through, and the use case is from Python. That was something I chose because I was working on trying to implement ArchiveSpace, and the people who were doing cool stuff with ArchiveSpace was almost exclusively done in Python, so it dovetailed nicely. Ruby is another Ruby is another higher level language. It's not as intuitive to me, but it might be very intuitive to you. People who use it love it. So I would say that's another thing to investigate. JavaScript is more than just web programming. It's something you can do to use to accomplish a lot of other tasks. There's a lot of paradigms out there like Node.js, which are very useful. I don't know anything about Node.js, but I just know that I know people who do, and it's amazing. And then PHP, also something that was developed for the web, is something that people use to accomplish tasks outside of web development. You can do a lot of file manipulation and so forth with that. So if it's not clear yet, these slides have a lot of embedded links to help you try and get to the resources after this is done. So if you want to download the slide set afterwards, this might be of benefit to you. All right, so let's say that you've chosen your language and it happens to be Python, or maybe it's not Python, but you've chosen the language to pursue. The next question, and this is the thing you want to take notes on if you don't catch anything else from this presentation, is knowing the resources that are available to you so that you know you can move forward and continue learning how to do things. The first resource is going to be forums. Once you get over the steep learning curve of trying to figure out how programming works in a particular language, doing things like help or manual pages are very useful, especially learning new functionality that you may, in your wildest dreams, have never thought of as something that could work, and then now you have even a cooler ability to do stuff. But it's listed second because when you get stuck, if you just type in the magical internet search box with Google, how do I do this task, and you describe it in Python, first few hits are probably going to be things like tutorials from sources that may or may not be questionable, but within that first page, you're always going to get some kind of forum where someone else has asked the program community saying, I don't know how to do this. Can someone help me out? This is what I've got so far. And working from that, you can then you can look at how that problem was solved and hopefully reverse engineer a solution that works in your particular case. So that's why the manual pages are actually listed second. Online tutorials are very good. There's a few out there that are just clickbait, so they'll slow down your computer, but a couple of good ones are Programming Historian. That's dedicated mostly to the case of digital humanities and analyzing historical documents, but it's a great way to get your feet wet and to get around some core concepts that are involved when you're working with programming. And it covers more than just Python. It covers many different programming languages. Code Academy is something I haven't actually used, but it is incredibly popular. I've known many people that have used Code Academy to access programming knowledge, not just in Python, but in other languages. I've never heard a bad review, and it's fairly affordable. All things considered, definitely more affordable than a college course. And then another resource is getting a pre-canned setup, such as Anaconda, which is a Python setup that's designed specifically to give someone in data science all the resources they need in that programming language to get the job done. So here we go. Let's say that you're moving forward with this. The next question is, what are you going to do in terms of making your scripts or programs? And I'm going to use that term interchangeably. There's probably a semantic difference, but for practical purposes for us, we're probably not developing web apps. So if you type out a really cool script and you want to call it a program, I don't think that anybody's the police are going to come on knocking on your door saying that's not right. There's basic straightforward options. If you want to hoard your programming knowledge so no one knows what you did, you can always type the programming script directly into the terminal or PowerShell or command line, depending on what operating system you use. But that's not so good if you want to be able to do the same thing over and over again or keep track of what went wrong if something did go wrong. So I would recommend at the very least doing advanced text editors. That's going to be something like SciText in Linux, or I'm trying to think of one that's in a Mac, but Notepad++ is my favorite for Windows. And what that'll do is if you can give it a clue as to what programming language you're trying to write through, either through something in the first few lines of the document or through the file extension, it'll color code the text based on the syntax of that language. So maybe there's basic keywords that are involved, and it'll highlight it in a certain color saying this is a keyword that you're trying to tap into, which means you can't use it in another way. And it'll also help you keep track of spelling of things, so that if you, say, want to call a variable Megatron because you're having fun with Transformers that day, and you try and spell it Megatorn, later on, it'll say, yeah, that's not actually a word that's in this document just yet. If you want to go really fancy and really get a good environment going, the best practice is probably an integrated development environment, such as PyCharm or Jupyter Notebook. Now, those are special environments that have the advanced text editor function, but there's much more that it does. You can create virtual environments in your computer so that you can play with what modules work best for what situations. And we'll talk about modules in a little bit, just like we'll talk about keywords. If you're loading a particular part of Python, of a language like Python, and it's got special functions, and you start typing, trying to tap into the functions, it might actually give you the function options that you can choose from and give you help text on how to fill it in. And you can also typically run your script or program in that test environment using a debugger so that it can give you good ideas of where things have gone wrong if something's not working the way it's supposed to. And as we can see from the chat here, everybody loves Notepad++. I've never actually met people who don't. Another good one, if you want an advanced text editor, is actually JEdit. It's got a lot of extensibility if you're looking for something else on a Windows machine. So modules are, let me make sure I got this right. Okay, yes, that's right. Modules. So modules is a way that a programming language gets itself extensibility. With the module, you're dealing with something that's not part of the core programming language. For instance, Python has a core bit of programming of the program that is going to be constant anytime you call up Python 3 or Python 2, but it's kind of bare bones. And then people use modules to extend that functionality around a certain use case. So for instance, people might have a set of functions that they've created that do special work around manipulating XML. So they create a module that they share with other people that lets you manipulate XML, and then you can just load that specific part without the high overhead of loading every potential use of a programming language, which would significantly slow down your computer. In theory, you can write your own module. People do that. LXML, I believe, was developed by one person who wanted to manipulate XML. But more likely, if you're tapping into a community module, it's been developed by a community of people. If you're working with Archive Space, for instance, there's a module that was developed called Archive Snake, which is an aggregation of all the different Python scripts and functionalities and that people had been consistently enough using that it would be useful just to be able to tap into it real quick. And another benefit of the module system is keywords are not something you can use except for to tell the system that you're trying to do something. And some modules use specific keywords that limits the vocabulary of options you have out there to be able to assign variables, which again we're going to cover in a second. So my favorite options are listed on the right here. OS and system is, or sys is something I load every single time because it's just basically interacting with the file system and the operating system. CSV is great for working with Excel files or CSV files. Pandas is a very, very powerful data manipulation module that is used in data science extensively. And then matplotlib, if you like doing pie charts, which is something I like to do a lot when doing things like giving management analytics data for web usage, that's a really good thing to work with. That particular one is very hard to figure out, but once you figure it out, it can do a lot of really cool stuff. All right. Oh. Now, time for the core start that we're going to work with. Variables, text, integers, and keywords. And this is all in one spot because it all kind of works together. And the reality with starting programming is that it's this circular kind of ecosystem where you're trying to break through this outer shell to figure out how things are working. And then once you are able to figure out how everything's interconnected and works with each other, it becomes a lot easier. But this slide probably, if you're beginning, doesn't make 100% sense until you start getting the other parts that are related. And you can already tell that I've referenced things like keywords and variables a couple times in the other slides, even though this is when we're first starting to talk about it. So a variable is something that you assign a value to. It's just that straightforward. What you do is you write whatever name you want to give it, except for, of course, a keyword, and you say equals something. Now, something can be a number, it can be text, it can be the output of some module function that you've decided you want to save. But when you have a variable, the computer saves that as something to use later. Now, let's see. So if you look at lines 7 and 8 on this slide, I apologize if it's a little small. You'll see that they both start off with kind of a silly name, but then equals, and then I say, give me a name of something, and that's a variable. The next thing to consider is text. So text is indicated by opening and closing parentheses. It can be parentheses, double quotes. It can be technically be double quotes or single quotes. If you're using an apostrophe, that counts as a single quote. Now, the opening and closing quotation mark has to match. You can't open with a double quote and close with a single quote. But the benefit of that is if you have quotes within the middle of the text you're working on, and you need to say, I'm going to have double quotes in here in the middle of the text, you can open and close with a single quote, and it'll still work just fine. It'll save that text just like plain text in a text file without trying to do anything. If you try and work with text without doing the quotes and just try and type it out, the moment you have a space, it's going to try and do some sort of operation on that, and it'll honestly fail. So the quotes are very important. So integers are, if you remember, I think it was high school, it might have been middle school. It's all kind of fuzzy now. But math back in the day, integer is just another way to say a number. This is differentiated from a number that's in text in the way it's encoded and then the way that the system handles it. So if you have a 0 in text in a text quotes, it'll just treat that as if it's as part of the line. But if you have a 0 outside of it, it'll treat that as the number 0 that you can then do stuff with, like multiplication, subtraction, division, that sort of thing. And you can't intermingle text and integers. There are cases where you can, but it's probably just worth it to say it's better not to. And then keywords. This window on the right is a Notepad++ window where you can see things are highlighted. Anything in blue there is a keyword. And those are the system terms that tell the programming language what to do. And it can be module specific, and it can be more general programming language specific. If you're using advanced text editor and you're doing you have a keyword that's module specific, chances are it probably won't highlight the text in color. But if you're using an IDE of some kind, it most likely will. So that's one of the benefits of using a development environment program like PyCharm over a Notepad program. Okay. So, commenting. Commenting is something that takes a little bit of footprint in a text file that you make a script out of, but it's well worth the investment, at least in the one that you save on your hard drive. If you want to make a comment, like in Python, and actually if you want to do that in Ruby, you precede the comment with a pound sign, and then anything after that on that single line is going to be part of the comment, and the computer will not do anything with the text. It doesn't work with multiple lines. You can't make a pound and sign and then just continue making lines, and then 3 lines later or 5 lines later try and end the comment. As soon as you hit return, the comment will end. And you can see on the first 3 lines there, I had to use a pound sign at the beginning of each line. It's really useful for telling people what's going on and for a reminder to yourself on what's going on, so that if you need to go back, you know what to change because it's not working the way you want to, or if you want to tell other people as well if you're into sharing and stuff. But a good practice is to keep it short. I can't remember the character length people recommend, but the recommendation is fairly short, much shorter than what you see on lines 1 and 2, because I'm not the best at keeping the essays short in my scripts. Okay, so a really strong suggestion I would like to make at this point when you're working in programming is to make your script a text file as opposed to doing some kind of entry into a terminal window. Now, I don't mean like file extension .txt, because if you're in Python, it's the extension's .py, but write it down in a file that you save separately. It works a lot faster for some weird reason, or at least it works faster on my computers, than if you manually type it. It's easier to error check if something goes wrong. If you remember Ronco back in the day, you can set it and forget it, let it run for however long it needs to run, and when it's done running, it'll just exit itself. And if you have that same situation come up again, you don't have to remember how you did it before because you've already got it written down somewhere else. I also recommend that you make your script as reusable as possible. The input core functionality in Python is good for that. So if you have a variable like we had in the previous slide, logo on line 7, you can see that I'm saying input and then image to copy. Just giving a file name there, this is reusable from a basic use case that's just one situation to now it can be reused by me or anybody I share it with to do the same type of task. And it saved me quite a few times when I've tried to do stuff, because you'll end up reusing things over and over again. All right, so not the last slide, but one of the last slides before we walk through an example is Boolean logic. Programming, unless you're doing AI, which AI uses statistical probability, took me a long time to figure that one out, is based on binary choices. Logic such as yes, no, or using if, else, or this, you do this, otherwise do that. And almost every problem you're going to face in the world, you can actually do through Boolean logic. It's just our brains do it a lot faster, or we're capable of choosing amongst 3 to 5 choices without actually going through that decision tree. But a computer has to have that yes, no type of logic to apply to a situation for the most part. I'm sure there are caveats to that, of course, but for the most part, that's how you have to work on it. So if you have a problem, it's really good to map out the problem as a word problem and then create a decision tree to help you navigate around how to solve that problem. So this is a real-world situation that happened to me. We have a massive digitization project that's going to take probably 10 years. We're several months in, and then the people in the digitization in a far-flung part of Texas decided they were going to add a new type of metadata to the metadata files. So we're using one metadata file per one digitized thing, and then it's going in the preservation system. Everything up to that point had been put into the preservation system, and everything was intermingled. They added this tag, and this was a tag that was not necessarily unique to those files, but that particular type of document, but it was something that hadn't been in that type of metadata file before. And each of the metadata, each of the 3 document types that I had at least one unique tag, but almost all the other tags were shared. So the solution that I came up with, and I am underscoring the A solution because there's multiple ways to skin a cat, and this is what worked for me, but it's possible that you can come up with something even better or elegant that does it in less time and does it better, or maybe it's more verbose, but it works just as well. So we might be facing similar problems and come up with different solutions. But that solution that I came up with was to read a metadata file and look for a unique tag in record type 1. If it's there, skip it, move on. Do the same for record type 2. And if it's there, skip it, move on, because if I have those 2 files, those 2 metadata files with those unique tags, it's not going to apply. So that leaves us with the third type. And if that tag does exist, it means it was after they made this decision to add that new bit of information, so I can chuck it. And anything else that's left from these files is what I need to insert that tag into. To give you an idea of the numbers, this was about 10,000 files, and it was about, oh my goodness, how much was it? 1,500, 1,000 files that needed metadata corrected, and it was all mixed in, so there's no way to tell which of these it needed help and which didn't without either doing this or manually checking every single one. So this is the actual example, and you can see I'm importing a module up at the top, and then I'm telling it variable 1 is just go ahead and give me the file path I need to crawl, and then from there, for every file, open this file, read the information. If there's a metadata, if there's this tag in there, move on. If this tag's in there, move on. And then if this tag again is in there, move on. Otherwise, insert this piece of information. And I apologize that we're going through that so fast. It's pretty complicated, but it actually worked fine. So the thing with Boolean logic, if you apply it once you get used to doing these decision trees, is it makes it seem like something's really intelligent when it's really not. And so there's a whole slew of memes out there about how it's just a bunch of if statements. It's not actually smart at all if you go down and look at the programming. And this one's probably my favorite. Guy 1 is trying to sell us some sort of cool AI, and then the programmer goes in, tears it apart, and just goes, nope, it's just a bunch of if statements. Don't talk to me about AI. All right. I'll go back to let people see that one more time. It's funny to me, at least. All right. So, file handling. If you are going to be working with things like metadata files, or actually normalizing files if you don't have a preservation system, but you do have a repository or you're using a file share of some kind, knowing how the system works with that is important. And computer systems generally work under the CRUD principle, which is just very straightforward: create, read, update, delete. If you're interacting on the back end through an API, that's typically with a repository, that's basically what you're usually telling it is create this or update that or delete this. And in Python, the create function is telling it to open. You give a file name, and then in quotes W, which stands for write. If a file already exists with that name, it'll overwrite that file. If it doesn't, it ends up creating the file. The read function is open and then parentheses the file name with a comma and then quote R, which stands for read only. Updating is a lot like create, but with a big difference. So you're going to open the file and give the file name and then comma and A, which stands for append. If the file doesn't exist, it will create the file, and if the file does exist, it'll add whatever you want to the end of the file. It sounds like a safer way to go, unless, of course, you're trying to overwrite all the data in a file, and you need it to be 100% replacement rather than appending. Or the reverse is true, where you're trying to just update a small bit of text rather than rewriting the file altogether. All right. And then delete really varies by module. If you're going to be using something like the OS module, the remove function works, but other modules that you might be using will do it with a slightly different syntax. How are we doing on time? We feeling good?
Hey, Brian, we're good. Probably wanted to shoot for 10 till for questions.
Okay. All right. We're going a lot faster than I expected, so I don't want to overshoot it. All right. So now we've covered basic file operations. It's time to talk about indentation and then order of operations. So code is executed in the order it was written, which means that you can't tell it to do something in line 9 and then have it try and do something that's in line 8 to the same file. It'll always do it in the specific order. There's an exception when it comes to calling a function, but that's way beyond the scope of what we're doing. And that's something I can chat with other people about later, although writing functions isn't my strong suit by any means. And when you're working in this order of operations, contingent code is something you're going to be working with a lot. So you're going to be telling the system, all right, do all of this in this particular order, and once you're done with doing this for this reason, move on to the next task. So if you have something that is contingent, the parent process should end with a colon, and then you'll either do a tab or a space to indicate something's a child of that particular process, and then you just continue moving through to get the task done. And that will execute iteratively. So for instance, in this example on line 9, I am telling it with open, the name of the file I gave, read this file, and then for each line in that file on line 10. So everything's based on line 9. In line 10, it's just going to go through line 1, do everything below, line 2, do everything below, and just keep going until it's done with all of those lines. And then by unindenting line 20, it's saying, okay, once all that is done, print, in this case, something that says all done. Okay, so that kind of dovetails into iteration and contingencies. So iteration is indicated by certain keywords such as for, if, while, try, and that tells the system that you're going to be doing something that is going to iterate over a certain type of thing. So you can say for this directory do that, and it will take that child process and work on it. If is going to be a really common type of iteration you're going to use, and then you're going to see when you're looking at other people's code, it's going to be if, and they might say elif, which is abbreviation for else if, and the last one's going to be whatever they're using, going to say else, which is if nothing else, if this other thing doesn't apply, if all these other things don't apply, do this last thing. With Python, the else is implied, so if you just never put an else, it'll just ignore whatever you're working on because all the rules that you said it should follow don't apply, and it'll move on. So that brings up next is the for and while loops. So what I mean by loop is it'll just loop through and through this process until whatever condition you have is met. So in a for loop, what you're telling it is for each thing in this whatever you're working on, do this task. Whereas a while loop tells the system while the file name is this.txt, do the following. And if that becomes untrue, then it stops doing the process. Try is going to be a lifesaver for you when you're starting because it's a lot like if or for in a lot of ways, but the difference being that you're telling it to try to do something, and if it doesn't work, it hopefully will prevent the task from crashing altogether. In some of the other loops or contingencies, if you don't have something like a try, then it will just completely crash everything. And try works with except. So when something fails in Python at least, it will raise what's called an exception, and it'll give you an error message saying this didn't work, here's why it didn't work. It's incredibly hard to divine from the error message what it is that went wrong, but will tell you. But if you do try and then say, okay, that didn't work, if you get an exception, do this other thing, then it will actually save you and let you move on without having everything crash. And in some cases, like trying to find files that are bad XML, you're actually testing for an exception because a bad XML file won't parse, and so you can spit out a message saying this XML file is invalid. And then another iteration or contingency is with, and then whatever you say as a letter, a number, or well, not a number, but some kind of text, X, Y, Z, whatever. And it's basically saying everything below this should be based on that. All child processes should be based on this thing. All right. You are at some point in your programming going to end up realizing you made a mistake, and hopefully nothing has gone wrong yet, but something will go wrong if you don't stop the script right now. Now, you can close the window that's running the process if you want, or you can tell it to halt If you want to tell the system to halt doing it, you just press Control plus C, as in Control C, like Control Copy, and it'll stop the process that's running. If you're working on writing a text file, like let's say you're transforming metadata from one schema to the next, and you press Control C, you will actually not get all of that stuff written, so you might have a blank file. But other than that particular situation, it should stop without doing any damage, for the most part. This is going to be different from if you need to copy something from the last time you did something in the command line to the current time you did something in the command line, which is Control-Shift-C. And then if you copy that text, you can just say Control-C where you're supposed to copy it to. Not Control-C, Control-V where you're copying it to, and it will copy that text over. And that should save you from accidentally escaping a script that you want to keep running, and at the same time keep you from running a script that you need to stop right away. And this is where I had plans for doing several walkthroughs of scripts I've used that ended up letting me convert a database to individual one item per digitized thing metadata files. And I do have to give major props to Alejandra Dean at this point, because she really helped me work out the creating of the actual XML files from what ended up being a very massive master spreadsheet. So thank you. I don't know if I've said thank you enough for that, but thank you. Before going on that, I figured this would be a good time to cover questions.
Sure. Okay. I don't see a whole lot of questions in the chat box. If you have a question, go ahead and chime in on the chat box and let us know. Are aware that this is a somewhat heavy presentation with a lot of information in it. So, like I said, the slides will be available through COSA's website afterwards. If you go to statearchivist.org and then under Programs and go to Videos and Recordings, you'll be able to navigate to the SERI training recordings, and so you'll be able to download the slide deck as well as the recording if you decide you have questions later.
Right. And I know that my voice can be a little bit monotone, so I apologize for putting anybody to sleep, but it is a lot to take in, as Morgan says. And you probably will come back later in an hour or two and go, wait, what did that mean? So,
well, Brian, while we're waiting on people to get questions, I guess I should ask, since you were coming at this from not having done any sort of programming in school, what was it that that sort of tipped you over the edge into doing this? You know, when did it become, you know, not just necessary and scary, but necessary and you were willing to tackle it?
Okay. So we use the Preservica digital preservation system, and we have a very robust digitization program. What's happened for us is we changed metadata schemas from Dublin Core and EAD to qualified Dublin Core that merges the two. And we also found that human error has created a lot of duplicate terms that are simple misspellings, like someone capitalized an S when it should have been lowercase, or vice versa. And so when people were using the front end of the system and it had facets, to the computer that was completely different things, because on the byte level it's different. So that was the impetus, is to normalize that. And we were able to normalize it from about 1,100 subject terms, which is, as anybody can say, is like crazy large, down to a much smaller, I'm going to put a big question mark on that, 900 terms that needed to be, that were normalized to something else. And then eventually that led me to doing this database project where I created something like 2.5 or 3.5 million metadata files using just spreadsheets.
Right. So looking at making, you know, tasks that are monumental and ginormous because of them being electronic records,
Right.
a little more manageable.
Right. So a practical use case that y'all might come across is, let's say that you have a bunch of photos and people put keywords into the photos and you receive it and you realize, okay, I want to make these keywords explicit and something people can search on. They'll see that John Smith is a name that's in there instead of having John's photo come up and you don't know why. You can use programming to pull out programming away. You can use something like ExifTool to extract the metadata, and then programming to manipulate it and do some wizardry to then put in your system those as official subject terms that people can search on.
Okay. While we wait on maybe some more questions, Becky has copied into the chat box the link for the recordings that you will have access to after the fact. That was what I was referencing earlier.
Okay. I'll move the slide up real quick to my contact information, which needs a quick explanation. All right. So if you have questions later on, I have my work phone, but I have 2 email addresses. The reason I have a Gmail address is if you email my work address as part of General Records Management, I do keep that email. So if for some reason that bothers you, you can contact me on my Gmail. But obviously the texas.gov email address is probably preferred.
All right. Well, Brian, since we have just a couple minutes and we're still waiting on questions, can you briefly cover your walkthrough? Would you be able to do that briefly, or does it take a longer period of time?
No, we can definitely cover the first one. It's pretty, I'm not going to say straightforward is the way to put it, but it's at least short.
Okay.
So in lines 1 and 2, we are importing modules. Pandas is, as I mentioned before, really great for data science. And you'll see I'm saying as, and then I'm giving initials. So in Python, what you can do, if you don't want to type something like pandas every time, you can say as and then the name, a different name, and anytime you use that different name in the script, it will call that up as if you were spelling it out longhand. Also on line 2, you'll see import lxml.etree as et. When the .etree, what I'm doing is calling up just the etree functionality of the LXML module. So if you have a massive module and you only want to load part of it, you can say the module name dot the sub functionality and import just that bit. So in line 6, I'm saying variable df1 is what you get if you use pandas to read a CSV file called tableimage.csv. And when I do that, it reads it into memory of the computer. Variable df2, I'm doing the exact same thing, but I'm having it read table correspondence link.csv. So now I have 2 spreadsheets loaded into the memory on the Python script. And moving on to line 11. So I have the variable df1, and I'm saying, okay, for this variable, the columns in the variable, rename the column names to this set of names, which ended up in this particular case being the tag names I used in the finished product. Variable 12, a variable writer on line 12 is saying, okay, variable df1, write it to a separate CSV file. In line 13, I'm redoing the same thing that happened in line 11, And in 14, I'm reusing the variable writer to write variable df2 to a CSV file. Now, this is kind of useful to know. You see that I reuse the variable. If you create a new variable for every single thing, you can end up using up way too much computer memory and crashing your computer. I've done that, so you can take my word for it. By creating this variable again, it's dumping all of that first variable output and creating a new and overriding it with this new variable output. All right, so let's see, line 17, when I'm saying I have variable results equals what happens when you merge df1 and df2 on the column name, image name. And then if people are familiar with SQL, SQL joins, I'm telling it using a SQL outer join as opposed to an inner or left or right join. And so it's mashing that data together without taking out any, without dropping anything, even if they don't have a match in that particular column. And then in column 20, I'm reusing writer again to write out the variable results where we merge the data to a new file. And then at the very end, I'm printing out the first 5 rows of results to basically test out to make sure the output was correct.
All right. Well, Brian, I do have a question. Since some of this is stuff you've put together, would you be willing to share files with anyone that gets in touch with you to use as a template for what they might want to do with their institution?
Yeah, I'm an open book. Give me a call, email me, and we'll see what I can share. I don't think I've ever been able to tell people or had to tell people, no, I'm not going to give you that information.
All right. Well, I don't see any more questions, so Becky, if you could hand control of the slide deck back over to me, we'll move it back to Brian's contact information for just a second. So if you want to get in touch with Brian, like you said, this is how you would do that. Give everyone a minute on that page, and then we'll wrap the webinar up. We do want to remind you that when you close out of the webinar, and I know a couple people have already left, you will be asked if you would like to complete a brief evaluation. So please do that, because that'll help us figure out what to do in the future for other webinars. So just take a couple minutes. It really won't take long. I am also inclined never to do these evaluations, but it does not take long at all. So we do appreciate the feedback. Please do stay connected. This is the COSA website and the Twitter handle and the Facebook page. You can stay abreast of future webinar offerings there. And then really that's it. So I just want to thank Brian for taking the time to lay all this out for us. It sounds like there were some useful starting points and useful bits for people who have gotten a little more in depth, but I'm sure I will probably be getting in touch with you at some point, and I'm sure a few other people will. So thank you for taking the time to go over some of what you've done with us. And thank you to everyone who came and attended. Really appreciate it. And please do let us know in the evaluation your thoughts. And hopefully you can join us for the webinar next month, December 17th, with Nick Canizzo on digital preservation workflows.